Hello everyone, welcome to interactive classes. Today we will learn about electromagnetic induction and also Fleming's right hand rule. In the last video we have learned how an electric motor works. If you haven't watched that video, please go in the link provided in the description box and you will find there. I hope you like today's video. Stay tuned. In the year 1831, a physicist named Michael Faraday proposed the theory of electromagnetic induction. We know that a current carrying conductor, when placed in a magnetic field, experiences a force. Now, Faraday observed the reverse is also possible. That means, if the magnetic field linked with the conductor is changed, then we generate a current inside the conductor, which is known as the induced current. So how that it works, let's see. Suppose this is a coil made up of copper wire. This is a galvanometer G. Now if we bring a magnet like this, and if we move the magnet in and out of the coil like this, repeated motion in and out of the coil, then we see the galvanometer shows a deflection. The pointer of the dial moves to the right side, right? This shows that there is a generation of electricity within this current coil, okay? So the next part is how to determine the direction of this induced current. Another one, Fleming, renowned scientist, proposed the theory of Fleming's right hand rule. In the previous videos we have learned the Fleming's left hand rule. In this video we will learn about Fleming's right hand rule. So how does it work? Fleming's right hand rule says the motion of the conductor, the field and the induced current are mutually perpendicular to each other. That means if this is the motion of the conductor or magnet. Now the basic funda is we need to change the magnetic field. We can do this by two methods. First one is we can move the conductor, or the second one is we can set the magnet in motion. In both the cases it will result in change in the magnetic field of the conductor. Okay, so this is motion of the conductor or the magnet, this is the field, and this is the induced current. So we take this like this. This is the thumb, this is the index finger, and this is the middle finger. The thumb points the motion of the conductor, the index finger points the magnetic field, and the induced current is pointed by the middle finger like this. So the basic usefulness of this property is, if a question comes like this, find out the direction of induced current find out the direction of the induced current from the figure. And in the figure we have the field is given in this way like this, B. The motion of the conductor may be given within the plane of the board. That means it gets straight inside like this. We point it by this symbol. So that means it is inside of this, like this. Okay. So we need to find out the induced current from the figure. So what we do is we use Fleming's right hand rule. So the motion is within the board like this. The magnetic field is in this direction. Fine. And so we have the induced current in the upward direction like this. That means magnetic field will be like this. This is in the upward direction. This is inside the board. The motion is within the board. You should not be confused with these two. This is inside the board and this is upward direction like this. Okay, I hope this is clear. So today we have learned how this works, the Fleming's right hand rule and electromagnetic induction. I'll provide the definition of this electromagnetic induction now. This will be helpful for your exams. The definition mainly comes for a mark of 2 or 3 in your exams. So what is electromagnetic induction? Like, the definition is the process by which a current can be induced within a conductor by changing the magnetic field linked with another conductor is known as electromagnetic induction. The process by which a current can be induced within a conductor by changing the magnetic field linked with another conductor is known as electromagnetic induction. So the thing is, we need to change the magnetic field linked with a conductor. So it can be self flux like this, self induction. That means if we change the magnetic field related with this coil, a current is induced in this conductor or coil. Similarly, there can be mutual induction too. That means if there are 2 coils like this, oriented in this fashion, this is the galvanometer. Okay, if there are 2 coils like this, and if we change the magnetic field related to this coil, we will watch a current is developed in the second coil as well. That means this is known as mutual induction. That means if we change the magnetic field with this conductor, a current is developed in this conductor too. As well as if we do the same for this coil too, we will get a current induced in this conductor as well. Now I hope this is clear for you guys. If you have any queries, questions or doubts, you can ask us in the comment section. We will try our best to solve your issues. If you like the video, please give a thumbs up and please share among your friends so that they also find it useful, and also subscribe to the channel if you like our videos and help us to grow. Thank you. Have a great day.